We all are made out of matter. You, I, planets, everything are made out of matter. And if you have powerful enough microscope, if you keep zooming in, you'll find that we are all made out of atoms. So most of our mass, not most, in fact, all of our mass really comes from the atom. Now, atom have two things inside them: the electron and the nucleus. Inside the atom, the mass really comes from the nucleus because electron has a very minuscule part of the mass, like 1 by 2000 part of an atom is the electron. The mass comes from the electron. The nucleus has again neutron and proton. And if you crack open a neutron or a proton, you'll find that it is made out of quarks. So really, most of the mass of the matter and eventually us comes from these quarks, which is just 1%. So where is the extra 99% mass coming from? Down quarks, two up quarks and a down quark for proton, and two down quark and an up quark for neutron. So really, most of your mass in your body is in those group of quarks. Nothing interesting there. But what's really interesting is what happens when you separate those quarks. Assume that these three balls are quarks and the bond between them are gluons, making sure that they are connected to each other. Effectively, this is proton. Now, if I take this proton and weigh it in the weighing machine, I should see its weight about 10 electron volts. But if I separate these, like remove these gluons, which are basically nothing but energy, if I remove these gluons and take measurement of these quarks individually, you'll find that together they make only 1% of the total weight, and this energy accounts for rest 99%. Now, these quarks hardly have any mass by themselves. They each weigh less than 1% of the mass of proton. And yet, when you put these quarks together, somehow their mass increases by a factor of 100. That's like putting 3 Lego pieces together and finding that all of a sudden they weigh as much as 300 Lego pieces. What's going on? Where does all this mass come from? The surprising answer is that the mass comes from energy that ties the quarks together. You see, one amazing fact we have learned is that energy acts like mass. If you have a bit of energy in one spot, say trapped in the bonds between two particles, that little bit of energy will be hard to push and pull in the same way that mass is hard to push and pull. If you separate two particles and let the energy dissipate, then particles will be easier to move around. Physicists have looked as closely as they can, and so far, particles like quarks and the electrons don't look like they are made of smaller pieces. This tells us that their mass doesn't come from the energy holding smaller bits together. So where does their mass come from? The original idea from 1880s was actually on the right track. Electrons are harder to move because of the magnetic field that they generate. But there's another field out there that also pushes back at them, the Higgs field. Filling the universe, this quantum field tugs at all of the matter particles, making them harder to move. This is where the mass of each particle comes from. But that's only the partial explanation. The full explanation is that the mass comes from energy of Higgs field. Some particles interact a lot with the energy stored in the Higgs field, which makes them harder to move. And some particles have weaker interaction, making them easier to move. In other words, the mass of each particle is really just the strength of the connection to the energy of Higgs field. And we can go a step further still. According to quantum theory, quarks and electrons themselves are nothing more than little ripples of energy in quantum fields that permeate the universe. A particle is just a burst of energy, same way that a shout is a ripple in the air or an ocean wave is a ripple in water. In other words, even the particles themselves are just energy. So what's the massive conclusion here? both of these clues, that most of the mass of an object is the energy of the bond that hold that object together, and that even the mass of each particle is really just energy, leads us to one amazing and somewhat shocking conclusion. What we thought of as a mass doesn't really exist. It's all just energy. This is how a rock in space is able to lose mass when it radiates a photon. It doesn't lose mass because it transformed matter into energy. All matter is already energy. So the rock just transformed energy from one form to another. In this case, it transformed the energy in the motion or vibration of molecules into a photon. So when you think of a rock in space, don't think of it having mass and energy. Just think of it as one big blob of collected energy. Some of that energy is in particles, some of it is in the bonds of the particle, and some of it is in the motion of the particles, but just one pool of energy. And that is why in E equals to mc square, one form of energy is really translated into another form of energy. The famous formula does tell us that there's a deep connection between mass and energy, but it's not that mass is something that can be transformed into energy. What we have learned is that all mass is just energy. It's energy of the particles of an object, either their bonds with one another or in their interaction with the Higgs field. The idea that energy has inertia or it weighs something feels odd and counterintuitive, but that's only because we have been thinking about mass the wrong way for hundreds of years. There's no such thing as stuff. It's only energy and the impact it has on the shape of space and how things move. Those are the two sides of Einstein's two-part relativity tango. Thanks for watching.